Welcome to example number 7. This question is about the addition of vectors by the means of components. We're going to solve this problem both graphically and analytically. We're given a hiker that begins his trip by first walking 25 kilometers southeast from the base camp. And we'll assume the base camp starts from the origin. On the second day, he then walks 40 kilometers in the direction 60 degrees north of the easterly axis, at which point he finds a forest ranger's tower. In question A, we're asked to determine the individual components of the hiker's displacement for each day. And in part B, we're asked to find the total displacement of the beginning to the very end spot where the hiker is. So we want both the magnitude and the direction of this total displacement. When we solve this kind of problem, one of the first things I will do is visualize the problem. So we're going to show this graphically, and we'll draw it out nicely, neatly to scale. So we're going to need a ruler and a protractor. You may want to go find one around the house and get started. We'll also solve this mathematically, which will be a much more precise method. So back to visualizing the problem. So already provided for you is a x and y coordinate system. And we can assume, I guess, along the positive x-axis, we'll call this east. Along the positive y-axis, we'll call that north. Along the negative x-axis, we'll call that west. And then along the negative y-axis, that's going to be south. Now what we're going to do is we're going to draw out each vector displacement. Let's start off with the first one of 25 kilometers southeast. Now if you look, I've already drawn a scale here for you, so hopefully you can just line up your ruler along here and say, well, how many centimeters is this roughly? And you want to make sure that first vector is 25 kilometers long. So whatever, measure out this length with your ruler. And we also have to draw that vector in the southeast direction. If they doesn't tell you what angle it is, you can assume that that is at a 45 degree from either the south or east axes. So to make sure you've got this out nicely done, why don't you grab a protractor and lay your protractor so the line is along your y-axis, and we want to go at an angle of 45 degrees right here. And there's my first vector drawn at an angle of 45 degrees to the vertical or the horizontal. I'm going to label that as vector A. Now the length of this vector A is 25 kilometers, that's the magnitude of it, and it's at an angle of 45 degrees here. Next, on the second day, the hiker walks 40 kilometers in the direction 60 degrees north of east. Now I need to add that vector at the tip of the first vector. Now before I go ahead and draw that vector in, I would suggest that you draw a mini little coordinate system here. Something like this. Now we need to have a vector that is now 40 kilometers long, so maybe take your ruler out and measure this distance, what this is in centimeters, for example, because you need to make the next vector that length, but at an angle of 60 degrees north of east. Now this is often confused by students. When we say north of east, we mean 60 degrees in the northerly direction, but from the east axis. So it's of the east axis. So we're going to go up 60 degrees from the easterly axis towards the north axis. So now I've laid out my protractor with my axes in here, and I'm going to draw my next leg, which is a length of 40 kilometers at an angle of 60 degrees from the easterly axis. So this is going to be going off along here now. And this we'll label as vector B with a magnitude of 40 kilometers, that's the length of this vector, and at an angle of 60 degrees north of the easterly axis. So if we were to find the resultant graphically, we would have a vector that starts here and ends right there. And this would be our resultant vector. Go ahead and put your protractor right along here and see what this angle theta is. We'll call that theta r for the resultant angle. I'm getting an angle of roughly around 25 degrees. And go ahead and measure this length with your ruler and compare it to this axis. And I'm getting something around about maybe 42, 43 kilometers roughly. So let's solve this mathematically. Let's determine the individual components of vector A and vector B, their x and y components. Let's break up this vector into its y component here and its x component here. We'll label this as A sub x and over here as A sub y. I'm going to redraw this over here as a triangle now. So now redrawn, I can find the x component ax using the hypotenuse of 25 kilometers and 45 degrees by using the sine of 45 degrees, which is equal to ax divided by 25. And cross multiplying, we get 25 times sine 45, which is root 2 over 2, or 17.7 kilometers roughly. So similarly, we can find a sub y by using cosine of the 45-degree angle equals ay divided by 25, which is also equal to 25 times root 2 over 2, or approximately 17.7. Now remember, we need to be careful with our signs. Remember, a sub x, that x component is going along the positive x-axis, so that's a positive component. But the vertical component of that vector a sub y is actually a negative value. So this really should be a positive here. So it was already positive, but I like to put plus and minus signs so I don't make any mistakes. And this is actually negative. So don't forget to put signs with your components. Next, let's take a look at vector B here. I'm going to change the color so I don't mix it up with components. Let's show the horizontal and the vertical components of B. And there we have the Bx component and the By component. Normally By would be shown over here, but I've moved it over here so that I can make the triangle right here instead. I know that this angle is 60 degrees and the hypotenuse of this vector B here is 40 kilometers. So now, what trig ratio would you use to find out the y component and the x component? You have two different ways to solve this, right? You could also label this angle up here being 30 degrees. It's up to you. The sine of 60 degrees, which is opposite over hypotenuse, would be equal to b sub y divided by 40. And b sub y would be equal to 40 times sine of 60 degrees, which is equivalent to root 3 over 2. Which is approximately equal to 49.0 kilometers. Now solving for the x component, the cosine of 60 degrees is equal to the adjacent side bx divided by the hypotenuse of 40 kilometers, which is equal to 40 times the cosine of 60 degrees, which is 1/2, and this reduces to exactly 20 kilometers. Well, let's clean this up a little bit now. And don't forget, we need to put appropriate signs. Bx is going along the positive axis, so that means that's going to be both positive, that's a positive component, and the y component is along the positive y-axis, so that's also positive. So the only component that is actually negative is the y component of the first displacement. So we have now solved part A, which is finding the x and y components of the hiker's displacement for each day. The next part we're going to do is we're going to find the resultant displacement, the magnitude of the total vector r here, the length of this arrow, and then the angle that it makes with respect to the x-axis. To do that, you need to add up all of the x components and all of the y components and find the total amount in the x direction and the total amount in the y direction. To help visualize this, I like to usually draw a chart. Let me show you. In the first column, you can call that vector. In the next column, we're going to add up all the x components. I usually abbreviate that as x comp. In the last column, we're going to add up all the y components. So we have two individual vectors. We have vector A and we have vector B, and we're going to be adding up all of their x components and y components. So we take a look at vector A, and we need to write the amount of the ax in here and the ay in here. Sometimes you may wish to do all that trigonometry you're doing over here and simplify it and just write positive 25 cos 45 and minus 25 sine 45. Or you could put these numbers in, these rounded numbers in. It's really up to you. So let's go on to the next vector, b sub x and b sub y. Put the x and y components over here. And don't forget to put the signs. I know they're both positive, but it's always a good check to make sure you have signs everywhere so you don't actually forget a negative that is on one of the components, like the y component of that first leg. Now you're going to find the total amount of the x components. So you're going to add this number, which is 17.7, plus this number, which is 20, and you're going to get an answer of 37.7 kilometers. And then we're going to add up the total y components, and we're going to have negative 17.7 plus 49, and this is going to give you an answer of roughly 17.0 kilometers. That's also positive. What you've just determined is the resultant vector along the x direction. So you've found the x component of that resultant vector, and you found the y component of the resultant vector. What you've done is you've taken this x component right here, it's 17.7, plus this x component, the b vector, which is 20, and you've gotten this length here. That's the x component of the resultant vector. Then when you added up the y components, you took this negative amount here, which was about negative 17.7, and then you added the y component of by, which is 49, to it, and you ended up with this resultant right here. These two vectors are always perpendicular to each other because they're along the x and the y axes, so these form a nice right triangle. Sometimes it helps to draw it out over here in a smaller little version where you show the Rx and the Ry. Particularly if you have one of these components as negative, and you have it not, you might make a mistake and think it's always in the upper right quadrant. So it's also to make sure that you've got it in the right final spot in your picture. And there's the resultant we're looking to find and the angle theta. So maybe it's a good idea to draw a triangle out of that. So to find the magnitude of the resultant mathematically using both the x and the y components, we're going to use Pythagorean theorem, which is the square root of rx squared plus ry squared. Let's substitute in. And if you plug this into your calculator, you're going to get an answer of 41.3 kilometers exactly, keeping all the digits along. And solving for the angle theta, let's say we'll just use the x and y components. We can use the inverse tangent of the y component divided by the x component, which will give you an angle of 24.2 degrees with respect to this positive x-axis. So then you would say that the resultant displacement of the hiker would be 41.3 kilometers, that's the magnitude, at a direction of 24.2 degrees north of the easterly axis. You could probably state this answer in different forms. You could use 41.3 kilometers as always the displacement, the magnitude of the displacement, but the angle could be made, say, with respect to the vertical axis, which would be 65.8 degrees. So you could say at a displacement of 41.3 kilometers at an angle of 65.8 degrees, but east of the northerly axis. So there's a lot of different ways that you could report your answer. You could also, since I've defined a positive x-axis, you could just say 24.2 degrees above the positive x-axis as shown in my diagram. Okay, that's it for this example in showing how to use the component method with vector addition.